In this video, we're going to talk about the 3D scanning, mesh processing, and the design of a wide-body fender using ExScan and Fusion 360, so stay tuned. Hey everyone, this is Matt with Learn Everything About Design, and in this video, we're going to do sort of an overview of the process we used to scan a fender, to process the mesh, and then to design a fender flare. We're using the supplied scanner from Shining 3D. It's an Einscan Pro HD. We're using ExScan to capture and process the data, and Fusion 360 to design the part. Now, there's a lot to cover in this process, which we did over a 14 plus part video series. So this video is going to cover the bullet points or the main points you need to understand when you're going through this process. So with all that out of the way, let's go ahead and talk about the different steps that we used to get this done. So the first thing we need to understand is scanning the part, then processing the mesh, aligning it to a coordinate system, and ultimately designing the part. Now, all of these have their own place in the process, but ultimately designing the part is going to take the most amount of time. With that out of the way, let's go ahead and jump into each step in the process. Remember, we are using a supplied scanner from Shining 3D. This is the Pro HD scanner. You can also do this with an Einstar or all the way up to the HX series. So the first step of this process is to decide which scanning mode you want to use. For this video, I'm going to show the rapid handheld scan. Once you pick which method you want to use, then you need to toggle all your different settings. Now in this case, we're going to do a hybrid alignment, which is using markers on the car as well as features. I'm going to be using the classic mode and then sort of a medium scan resolution. Once you set all of those different pieces up, you then need to set the brightness of your scanner. Making sure that your part isn't over or under saturated is going to be an important step to make sure you're capturing enough data that is clean and able to be used downstream. This process does take a little bit of refinement and playing around based on the color of your object and the quality of its surfaces. Once you get there, then you simply need to go through the process of scanning the object, in this case, a car fender. Now, this can take a good bit of time, and you can run into some issues depending on how many marker dots you're using or the features that you have for alignment. If you want to follow this, go to the description of the video and you can walk through it in real time. Once you've captured all of the different pieces of the car that you need, then the process of aligning those is next. So what we're going to do here is use the markers to align it, and it simply allows us to put all the scans together. And then once we have those aligned, the next step for me is to clean up the edges of the scans. Oftentimes you can get a little bit of noisy data on those edges. And if you have overlapping scans, which you should always do, then you can simply remove some of that data. This will help when you're optimizing and turning these point clouds into a 3D mesh. Once you're happy with all of the scans alignments, then you go ahead and move on to meshing the data. This takes those points and turns it into an actual mesh file that we're going to continue to work with. Now, the marker dots will leave holes in the mesh from the point cloud. The ExScan process goes through and it actually fills in those holes automatically. But what I've noticed, if you have too many marker dots, then oftentimes you need to go back and do a little bit of extra cleanup work. There are some initial steps when you're turning your point clouds into a mesh, and then there are some extra steps that you can go through to optimize the mesh, to smooth it, to do some hole filling, and some general processing. Now, all that information you can find in individual videos in the description of the video. From there, we then need to align the mesh to a coordinate system. Now, this can be done manually by rotating it around, or we can use a 3-2-1 alignment system, which allows us to create a plane, in this case, a line and a point. The plane will help us reference the normal direction of Z. The line can help us figure out an axis, in this case, X, and then the point will be the location of XYZ 0. This can be used for final or even just an initial alignment, and then you can use some of these manual movement options to get it the rest of the way. Because I didn't scan the ground or any perfect references on this car, I ended up needing to do a little bit of exact movement, which is essentially just giving it some extra rotation or movement to get it to the correct position. Now, in order to bring this into CAD, you need to save it out as a mesh, but it's important that you do align it to a coordinate system before you export it. We were using Fusion 360 for this and the freeform environment. The freeform environment or T-splines allow us to build a subdivided model directly on top of the mesh. Using these tools and using the face tool, we can snap directly to the mesh and begin recreating the original fender. A part of this process for me was keeping some of the original or OEM body lines. So I wanted to start by replicating the fender, or at least portions of it. And once we had those sort of base shapes down in what we call the box display, we can then move on to creating a wider version of that. The amount of time you spend working here is going to help downstream ensure that the end result is going to be as smooth as possible. Now, I say this in all my videos, but Fusion 360 and most CAD programs are not Class A surfacing. They're not meant to model cars, so you do as best you can with the tools you have. From there, we move on to simply building out the wheel arch, the location where we want it in space, and then bridging the distance or the gap between all of the pieces. This process, again, you can spend as little or as much time as you want here, but there's a lot of back and forth that happens in order to refine these shapes. When you're using freeform modeling, you need to be extremely careful with the way in which you design and divide up these pieces to make sure that you get good quality surfaces downstream. Again, bridging the gap between those pieces gives us a somewhat final result. Now, an important step for me is always going back and forth into rendering or visualization. I like to take a look at the shadows and reflections on designs to make sure that I'm going the right direction, to make sure that all of the edges are clean and crisp and how I expect them to be. Using this step is important to make sure that you don't miss any details or find any critical issues. Once we validate that, then hopping back in and doing some final refinement just to make sure that the part fits. This is intended to be an over fender, which means that the fit to the stock fender in certain areas is critical. So spending a little bit of extra time at the end of the design, ensuring that it does fit in the correct way is important to make sure that the end goal is right. Now, this part is designed to be 3D printed and ultimately a fiberglass mold to be made off of it, but the 3D printing is sort of an intermediate step. Once we have those final pieces of the puzzle, making sure that it is going to fit, moving back in and checking things like the zebra stripe or curvature map analysis. Now, once again, this isn't a Class A tool, but validating the curvature is another important step to make sure that the end part or the end goal is right. We can also use these tools to help us design additional components. For example, looking at the red edges on the curvature map analysis can help us design splines that can be used to develop things like vents or additional features inside of the fender. So in this case, using those lines on the curvature map to define the boundary in the area for a vent and designing that to fit into the top of the fender. We can then take the surfaces, thicken them into 3D, and cut away any additional areas that we don't need. Building past where you need the design and then cutting away is a much cleaner way in order to get these good results. Once again, going back into rendering and validating the look of the various fenders, making sure that everything is okay, and then splitting or breaking this up into multiple pieces so that they can be 3D printed. Now, this part of the process does take a good bit of time, actually almost more than it takes to design the part itself. There are add-ins and programs that can help you do this, but oftentimes when we're talking about a part like this, an over fender, there are aspects where you need to really pay attention to how close it fits to the car. So I find that doing this manually oftentimes is the correct or the best way in some designs. So what we're doing here is simply just adding some flat faces. The intent is to glue these pieces together. Otherwise, I could add additional features. So for example, we could add little register holes or areas where we can screw the parts together. The top of this, the front of this, and the back of this will adhere to the OEM fender with double-sided tape. So we can use that as sort of a locator in addition to these faces that we're going to glue together. So with all that out of the way, once again, the overall process is to prepare your part, in this case a car fender, making sure that you have marker dots or anything that you need for alignment, then work through the scanning process the mesh, make sure that it's nice and clean and all the holes are filled, then align it to a coordinate system and bring it into the CAD system that you want to use. For this, we used Fusion 360 and we used the freeform environment to make quick work of creating these organic shapes without having to do things like sketches and build all the surfaces individually. This is a great way to work through the concept process and allow you to manipulate the designs very easily downstream. This is why we built the OEM shaped fender and then just simply pulled it out where we wanted and added the wheel arch. This entire process does take a good bit of time, but it is possible with tools like the Einstar or some of the Einscan series going all the way up to the HX. And using Fusion 360 is a great way because we can bring the mesh directly in and use freeform tools directly pulling or aligning to that mesh where we need it. At the end of the day, make sure that you do check the links in the description. This entire thing is done in real time in a series that has currently 14 videos and is still ongoing. And there are also individual videos in there for various scans. So if you have any questions on this process or anything that you've seen here, please make sure that you do leave a comment. As always, thanks for watching, and we'll see you in the next one.